Okay, Calculus AP Section 1 Part B. This is the calculator portion. I have my calculator. I hope you have yours too. So if you don't, pause the video, go ahead and pull it out. And we will get started here. So this says question number 76. They numbered it a little bit differently, but it still kind of goes in numerical order. But we're starting with 76. Particle moves along the x-axis so that any time t greater than or equal to 0, velocity is given by this. What is the acceleration of the particle at time t equals 6? Well, acceleration is really the derivative of velocity. So acceleration at time t equals 6 is really v prime of 6, or the slope at t equals 6. And so all we got to do is plug this into our calculator. We don't even actually have to take the derivative. You can calculate the derivative using your calculator at a specific point, like it is in this case. So I'm going to plug in that function. The function uses t's, but we use x's. Let's clear out these old functions from previous exercises. Go back to our y1. So the function that we're plugging in here is t squared times natural log of t minus, or t plus 2. That's the same thing as saying x squared times the natural log of x plus 2. And I know that I'm saying what is the derivative at t equals 6, so I need to at least go to 6. So I'm going to change my window from 0 to 6. Just look at that area there. Okay, so we have this huge function. It's going to be way up there. It looks like, oh, but you know what? My y values aren't very big. So let's get some y values going on here that are a little bit better. How about 0 for the y min? And we'll go up to, let's say, 100. Yeah, that does look pretty big there. So we need to figure out this slope right here. So if I drag this graph over and you guys can see what we're really looking at. We're looking at this slope here. Well, I for sure know it's positive, but it might even be as low as 1.5 here, because that slope does look about 45 degrees. It might be 20, but we don't know. Actually, it's probably going to be pretty big here, because this difference here is much greater than this difference here. So that delta y is going to have a much bigger value than the delta x. Alright, so let's calculate the derivative. Let's do it the simple way. Plug it into the calculator. We do second, then we go to the calc part, which is above trace. And we're going to do the derivative, which is 6. And what's the x value we want to check? It's also 6. Plug it in, 29.45. The answer is C. Cool. Number 77. If this integral equals 6 and this integral equals 4, then what's the integral of 3 plus 2 times f of x? The concept that's really happening here that we're looking at is the integral from a to b plus the integral from b to c is equal to the integral from a to c. Let's see how we can figure that out. First of all, this integral from 0 to 5 of 3 plus 2 times f of x is going to be equal to the integral of 3 from 0 to 5 plus 2 times the integral of f of x from 0 to 5. We know that this piece here, the integral from 0 to 5, is going to be the sum of the other two integrals. So this is going to be 10. We're going to multiply that by 2. Then we have to integrate the constant 3, which is really just 3x, and then that from 0 to 5 is going to be 3 times 5, 15. So 15 plus 2 times 10 is really 15 plus 20. All that put together equals 35. D. D. For t is greater than or equal to 0 hours, h is a differentiable function that gives the temperature in degrees Celsius at an Arctic weather station. Which of the following best interpretation of h prime of 24? So we're looking at the derivative here, the rate of change, in other words. So it's asking us about the rate of change of something that measures temperature in degrees Celsius. Well, that would be the average rate. No, it's not an average rate. We're talking about instant rate. And if it says 24, H prime of 24, the change in temperature during the first day, no, it's not during, it's at the end of the first day. The change in temperature during the 24th hour, not during the 24th hour, at the 24th hour. The rate at which the temperature is changing during the fourth, no, not that either. The rate at which the temperature is changing at the end of the 24th hour. So we're here at 24. We started at 0. And time is moving to 24, and we're looking at the instant slope right at 24, right at when time equals 24. So the day is over. We want to know that instant slope. A spherical tank contains, wow, that's a pretty specific decimal gallons of water there. For the next 6 months, water flows out of the tank at a rate of 9 times sine of the square root of t minus 1 gallons per minute. How many gallons of water are in the tank at the end of 6 minutes? So it takes this much. So it starts with 81.637. And I'm guessing this here is going to be a negative growth. It actually almost looks like it. So water flows out of the tank. So it's going to be minus the accumulation of this flow. So this accumulation of flow is going to be the integral from 0 to 6. And this integral here is 9 times sine square root of t plus 1 dt. So I got to calculate this integral, but then subtract it from 81.637. Let's see what we come up with. Let's start with that function. So we have sine of square root, which is going to be the opposite of x squared. So we got square root right here of t plus 1, so x plus 1. And we're going to be integrating this from 0 to 6, so we need our window to be from 0 to 6, which it actually already is. It's kind of interesting they have that set up so you don't have to change a whole bunch. I'm going to go from 0 to 10 for the y value here. Looks like actually it doesn't go over 1, so let's just go from 0 to 1. Just to give ourselves a picture of what's really going on. So there's my function. I need to find this amount of area, then subtract it from that original 81.637 gallons. So I'm going to integrate this, and that would be second. Calculate. Integrate is number 7. We're going to do the lower limit is 0. The upper limit is 6. And that value winds up being 5.003. 5.003. The only thing close to that seems like it would be this one here. So let's see, 81.637 minus 5.003. Well, that's got to be this one here. It's the only thing even close. So I'm not even going to simplify. I'm just going to guess that's got to be what we're looking at. For this next one here, we have a left Riemann sum, a right Riemann sum, trapezoidal sum are used to approximate the value from 0 to 1 of f of x. So we're going from 0 to 1 here. You each using the same number of sub-intervals. So what are we asking here? Which sums give an underestimate? Well, if we're using a right-hand rule, let's put it this way. If we're doing a trapezoidal rule, this is concave down, so the trapezoid is always going to be underneath it, so that's definitely going to be under the curve. If we're doing a left-hand rule, like a box, we're also going to be under the curve because we're going by the left side, which is under the curve. But if we're doing a right-hand rule, that means our box is going to go above the curve because it's coming from the right side. The height is coming from the right side. So the right sum is over, but the left and trapezoidal are both under. So that would be 1 and 3, or the answer is D. The first derivative of the function f is given by f prime of x equals x minus 4 times e to the negative sine 2x. How many points of inflection does the graph of f have on the interval 0 to 2 pi? So this is my first derivative. And how many points of inflection? So a point of inflection is when f double prime of x changes sign. And f double prime of x is actually the derivative of f prime of x. So this is the slope of f of x, or f prime of x, pardon me. So we're looking for when that changes sign. So let's go back and look at our graph. If we pull this up again, the function is, that's kind of complicated. Let's go and keep that there while we type it in here. It's x minus 4. Clear this out. We've got x minus 4 times e, which is second e. And then up in the top of that, we got negative sine of 2x. Negative sine of 2x. Is that right? Yeah, 2x. 2x. And then we close that off, and we'll close off the e as well. Remember, we're just graphing from 0 to 2 pi, so I'm going to go from 0 to about 6, but let's actually do exactly 2 pi, even though 6 is pretty close. So I'm going to do 2 times pi, second pi, which is 6.28. All right. So here is our function. We're kind of bouncing all over the place. In order to see what's really going on, we need to expand our y values. So let's go from negative 10 to 10, just for good range to see all the action that's happening. Oh, what did we miss? Oh, go back to the window range. We said, oh, we went too far down. So we need to go from negative 10 here to 10 for the next one. And this is going to be 1 for our scale. So remember, what we're looking at is for changes in slopes. When does the slope change direction? So if I click back on this original function, let's drag it over to our screen, so we can look at it maybe a little more closely. So I have this function here, and I notice that it's positive to start, but then it changes negative, so that means this is a point of inflection here. And then it's negative, and then it changes back to positive. So that means we have another point of inflection here, and another one here, and another one here. And it's actually where we have relative extrema. So we got 1, 2, 3, 4. The answer is B. B. If f is a continuous function on the closed interval ab, which of the following must be true? Okay, so we know it's continuous. That's basically all we know. Alright, there's a number c in the open interval ab such that f of c equals 0. Not necessarily, because if we're looking at the function of f, and this is f of c equals 0, it's saying that the function has a 0. Well, we know that f of c could be greater than 0 if this was the x-axis. It doesn't have to cross 0, so a is out. There's a number c in the open interval ab such that c is between those two. Well, not necessarily, because it's saying that a is less, that f of a is less than b. Well, what if f of a was greater than f of b, and c was in between? Then these two are backwards. F of b should be the smallest one, f of a should be the biggest one. So that's not necessarily true. There's a number c in the closed interval such that f of c is greater than or equal to f of x for all x in ab. That's saying that there is a maximum value, that it's the highest value in all x in the closed interval a to b, and that c is in the closed interval, either a or b, that there's some absolute max. Well, if we know that the function is continuous on the closed interval, that's actually probably true. I'm inclined to say that that one's true, but let's double check and see if we can find this other stuff. There's a number c in the open interval such that f prime of c equals 0. Not necessarily. It's saying that there's a relative extrema somewhere in there. There's a number c in the open interval such that f prime of c equals the is saying that the instant slope is equal to the average slope. Now, I would say that one is probably more likely true than C. So we're looking at either C or E as our answers. This bottom one is just another way of stating mean value theorem. And this top one is talking about the presence of an absolute max. And I know that mean value theorem is probably more likely as long as we're continuous. The only thing it doesn't really say, though, is that it's differentiable. And it'd have to be differentiable for it to be a mean value theorem. So actually, I'm going to cross out here. I'm going to change my mind here and go back to C. Because for mean value theorem to apply, you have to be continuous and differentiable, not just continuous. To have a maximum, you just got to be continuous. The function f is differentiable and has values as shown in the table above. Both f and f prime are strictly increasing, meaning that they're always increasing, never decreasing, on the interval 0 to 5. Which of the following could be the value of f prime of 3? Well, if we're looking at f prime of 3 and it's going from 39.2 to 48.5, you know, we're kind of looking at the slope here. What's this possible slope? So if we're trying to calculate the slope, I would probably be more inclined to use this side here. So we're looking at, we got a difference in x's is going to be 3.0 minus 3.1. And then the y's is going to be 45 minus 48.05. So that means on top, I'm going to really have about 3.05. And on bottom, I'm going to have 0.1. Another way of looking at that is about 3.05 over 1/10, which is really the same thing as times 10. So it's going to be about 30.5. Now, notice I did that by hand. That's kind of crazy. Now, just to confirm, let's see what it would be on the other side. So if we got 2.8 minus 3.0, that's my two x values, and my two y values then are 45 and 39.2. So 39.2 minus 45. Excuse me. So if I'm calculating this slope here, the y2 minus y1 and the x2 minus x1, it's going to give me my approximation, my nearby slope. So it could be about the instantaneous slope, which is what they're really asking. 45 minus 39.2 is 5.8. And on bottom, I'm going to have 0.2, which is really about 2/10. So we got 5.8 over 2/10, which is really equal to 5.8 times 10 divided by 2. Well, 5.8 times 10 is 58. 58 divided by 2 is going to give me 25 plus 4, so that's about, what's that, 34? No, not 34. 25 plus 4, about 29. Okay, so I'm inclined to say that it's either about C or D. Now, if I know it's strictly increasing, I might even be inclined to look at the difference from 39.2 all the way to 48.5 and take a more general slope kind of going there. Now, here's kind of what I'm thinking though. If I know that this is 30.5 and this is 29 on either side, so here's what's actually happening. On the left side, I know that my slope is 29. And on the right side, my slope is 30.5. And I know that it's increasing. F and F prime are strictly increasing. This means the slopes are increasing. It's at 29, it's going to 30.5. So what's in between those? It would have to be 30. So the answer should be D, 30. Not even 30.5 or 29. It's got to be in between them. And these are just nowhere near it. The graph of f prime, the derivative of the function f, is shown above. On which of the following intervals is f decreasing? So this is f prime. So decreasing for f means that f prime is negative. And it's negative here and here. So between 4 and 6 and 0 to 2. So 0 to 2 and 4 and 6. The answer is E. That was fast. Oh man, that was fast. Alright, what do we got here? The base of a loudspeaker is determined by two curves. as shown in the figure above. For this loudspeaker, the cross sections are perpendicular to the x-axis are squares. This is volume of the loudspeaker in cubic units. Well, if we're trying to find a square, the base of each of these squares right here, this is our base, our b, and our b is equal to the difference between those, which is x squared over 10 minus negative x squared over 10. If I put those together, I get 2x squared over 10, or really x squared over 5. So that's what my b, or base, of each square equals. So that means this distance here of the square is x squared over 5. That also means that this height here is also x squared over 5. So what I'm trying to find then is the integral, or the area, or the integral of these areas. So it's the integral of this area from, do we have a range here, from 1 to 4. So it's going to be the integral of 1 to 4, the area, which is those two pieces times each other. It's going to be x to the 4th over 25. This is just a calculator problem. Could do it by hand, but no reason to. I have a calculator, so let's use it. So I'm going to clear this graph. We're going to use x to the 4th over 25 now. So x to the 4th divided by 25. My interval needs to go from at least 1 to 4. I know that I have 0 to 6 from earlier. So now let's integrate this from 0 to 4, or not 0 to 4, 1 to 4. Second, calculate. We're doing the integral, which is 7. Lower limit is 1. Upper limit is 4. So we would get about 8.184. D is the answer.